Hi everyone, in this video we're going to configure recursive directly attached, fully specified and default statics route on Cisco router using a simple lab topology. Let's dive right in. Now we need to understand the topology. As you can see on the screen, we have a total of 5 networks in the topology, which means R1 is directly connected to the 2 networks, R2 connected to the 3 networks, and R3 is connected to 2 networks. To reach all other networks, we need to configure 3 statics routes on R1, 2 on R2 and 3 statics routes on R3. Now let's configure recursive static routes on R1. We'll open R1, enable configure terminal, and I type IP route 172.31.0.0 with subnet-mask 255.255.255.0 with destination 172.31.1 and 193. So this command tells us IP route means router you're manually defining a static route. Then this is the destination network, means the network trying to reach. After that, this is the destination network with our subnet mask, and the last IP means this is the next hop IP address, meaning the router will forward packet 172.31.0.0/24 to this IP, and we can verify our command with show IP route statics. Now I type the other IP routes. IP route 172.31.1.196 with subnet mask 255.255.255.252 172.31.1.193. Then the last IP statics route is IP route 172.31.1.128 with subnet mask 255.255.255.192. The destination is 172.31 and 1.193. Let's try pinging PC2 and PC3 from PC1, but it will fail because R2 and R3 don't yet have written routes. Now we switch to R2 to configure directly attached statics routes. These routes use the exit interface instead of the next hop IP address. We use the following commands. We open R2, configure terminal, IP route 172.31.1.0, 255.255.255.128 with serial 0/00. This command tells R2 how to reach to 172.31.1.0/25 networks. That's the LAN behind R1, using serial 000 as the exit interface. Now let's type another command. This is IP route 172.31.1.128 with subnet mask 255.255.255.192 with interface serial 001. This one allows R2 to reach the 172.31.1.128/26 networks, which is the LAN behind R2 using serial 001. To verify the routing information, we use show IP route static. This allows all statics routes in R2's routing table. Then we type show IP route connected. This shows only the directly connected networks. This is the attached static routes on R2. Now we jump to R3. We will configure a default statics route. This route handles any unknown destination not found in the routing table. Use the following command. R3 configure terminal, IP route 000 with subnet-mask 000 to serial 0/01. This tells R3 to forward all unknown traffic out of serial 001 toward R2. To verify the configuration, again we use show IP route statics. Now let's write the fully specified statics routes from R3. They use both the exist interface and the next hop IP address. Even though packet tracer may not accept them, here's how they are written. R3 configure terminal IP route 172.31.0.0 with subnet-mask to serial 001 to 172.31.197. This is the route from R3 to the R2 LAN using serial 001 and next hop 197. And we type these commands, and this is the route to the WAN links between R2 and R1. Then we type these commands. This one is for the R1 LAN network. Fully specified routes are useful for more precise forwarding, especially in the complex network. To test if the routes are working, we have PC1. Yes, we want to ping 172.31.0.10 and 172.31.130. If everything is configured correctly, you should now get successful reply from PC2 and PC3. That's it for this static routing lab. You've learned how to configure all 4 types of static routes and verify connectivity. If this video helped you, don't forget to like, subscribe, and leave your question in the comments. See you in the next one.